Welcome to every geometry student's favorite lesson, 2.4 postulates and proofs. All right, guys, buckle up. Here we go. Proofs. Now, you're going to see here today that proofs actually are not that bad. The thing that is difficult is learning all your new definitions and figuring out how to create the chain that is necessary to prove something. You do it all the time when you're showing work for algebra, so I'll show you that, but it's just kind of a different format. So first of all, let's get into what is a postulate. A postulate is just a statement that is accepted as true without proof. Okay, so we can all agree on something. If we all agree on something, it's a statement that we accept without proof. That's a postulate. So there's a number of postulates that we have in geometry. We're going to go over a couple of them for points, lines, and planes today, so please follow along in your notes and fill these out. But these are basically essentially definitions of what things are. So through any 2 points, there's exactly one line. So a line is made up of at least 2 points, and through any 2 points, there's only one line. 2.2 states through any 3 non-collinear, keyword there, non-collinear points, and my pen's not working, great. Non-collinear points, there's exactly one plane, okay? If they were collinear, it'd just be a line. 2.3 states a line contains at least 2 points, okay? So a little bit different than 2.1. 2.3 is saying a line has at least 2 points that makes it up. If there's only 1 point, that's just a point. 2.4, a plane contains at least 3 non-collinear points. So just like 2.2, this is just expanding that further and saying, hey, you have to have at least 3 non-collinear points to get a plane. 2.5 states if 2 points lie in a plane, then the entire line containing those points also lies in that plane. All right, and then 2 more here. 2.6, if 2 lines intersect, then their intersection is exactly 1 point. And 2.7 says if 2 planes intersect, imagine 2 pieces of paper intersecting, then they intersect at exactly 1 line. Okay, that's 2.7. So then example 1a says state the postulate that can prove it. It says points A, B, and C determine a plane. Okay, so 3 points are determining a plane. Interesting that it didn't say non-collinear points, but that's okay. So we could say, we could actually make an argument for either one of these. Through any 3 non-collinear points, there's exactly 1 plane, or a plane contains at least 3 non-collinear points. I think it more lines up with 2.4. So you could just put on your homework 2.4. You don't have to label the whole thing out. And then 1b says planes P and Q intersect at a line M. Okay, so 2 planes intersect at exactly 1 line. That is 2.7. So you would just write 2.7 and you're done. Okay, for your homework and for your test, I will allow you to bring your notes, which will have all of this stuff in it if you're filling it out. And you can simply just write out 2.7. Okay, so for example 2, it says determine whether each statement is always, sometimes, or never true, then explain your reasoning. Okay, so for 2a it says 2 intersecting lines determine a plane. So if you have 2 intersecting lines, okay, does that always, sometimes, or never determine a plane? All right, well, if you have 2 intersecting lines, we know that we have at least 2 points on each line, right? So there's 4 points there, and since those 2 things are intersecting, they're intersecting on one plane, one dimension, if you will, because they intersect at 1 point. So I'm leaning toward this would always be true. Okay, this is always true. And it says that you need to explain your reasoning here. Okay, so What is my reasoning for this? Well, between any two intersecting lines, there is always at least 3 non-collinear points, which is what makes up a plane, right? So if you want me to write that down, I guess I could do that. Between, let's just say between any two intersecting lines, there are always at least 3 non-collinear points. Okay, so highlighted here, here's 1, here's 2, here's 3, or you could have chose the other, the other dot and then had other point, I should say, and have the other 3 points. But no matter what, you're gonna if you choose any of those 3 points, they're going to be non-collinear overall. 2 of them will be collinear, but altogether, all 3 of them will not be collinear. For 2b, it says 3 lines intersect in 2 points. Okay, so 3 lines. 1, 2, 3. If they have 3 lines, do they intersect at 2 points? Well, it looks like from this example, they would intersect at least 3 different points if we have 3 lines. The other way that I could do it is I could do this, right, where they all intersect at 1 point. But I don't believe there's any way that I can get them to intersect in 2 different points. Okay, so for this one I will say never, and if you disagree with me, you can try to draw an example. But I would say never, because, that's my little abbreviation for because, in order for 3 lines to intersect in 2 points, 2 of the lines would have to be the same. Right, you'd have to have the exact same line twice in order for it to happen in 2 different places. So there's no way for that to happen if we're talking about 3 different lines. Okay, moving on to proof process. So here are the 5 steps